This presentation will be in English. I'm very happy to introduce the next speaker. His name is Thomas Beale, and the title of his presentation is OpenEHR Archetypes. Thomas Beale is a Chief Technology Officer at Ocean Informatics. He has worked in C&M Level 4 real-time control, large financial enterprises and telecommunications, before moving into e-health in 1994. Since 1998, he has been involved in international e-health standard development, such as OMG, HL7 and SEN, including participating in an IHTSDO technical committee member since 2009 to 2012, maintaining SNOMED-sete. He has worked on the OpenEHR architecture since 2001 and designed the Archetype Definition Language, ADL, and reference compiler, now in use by SEN, ISO, and CIMI. Please, Thomas.
Hi, good afternoon, everybody. Thanks very much to DIPS for welcoming me and giving me the invitation to come along and present to you. I'm going to talk about OpenEHR, so I guess at least 50% of you understood that this English pronunciation, OpenEHR, is a nice little joke, like being on the outside. Not everybody gets it. So OpenEHR, OpenEHR, right? Same thing. So why am I talking about this to you? Well, you had lots of presentations and you're there's a thing called archetypes in your midst, lurking inside DIPS Arena and even somewhat in the previous DIPS Classic, I think. So DIPS is just from an outsider point of view, this is a company that's interested in moving into leading edge technology, semantic health computing, and making some very interesting choices. So I think it's kind of relevant for you to have a bit of a picture. What is OpenEHR about? I mean, they can tell you and they can say archetypes are wonderful or whatever. I want to try and give you a bit of an outsider's perspective from the foundation where this stuff originated. But I also want you to think that in the future, the community, made up of just people like you, whether you're from the clinical side or the user side, or in the vendor side, so the DIPS side, software development, all of you people are really the future of OpenEHR Foundation, and it's the same in some other major locations now around the world where organisations are adopting this kind of technology. So I'm just going to give you a quick run through of what is this OpenEHR stuff? Why do we care? So a few simple questions. Why can't existing systems keep up with changing requirements? Now, I'm not talking probably about DIPS and Norway so much. I'm talking about the world in general. What is software like in general, and not even in health? Another question, why do we replace clinical information systems every few years? Around the world, that's pretty normal still, and I would say that even here, maybe the DIPS Classic to DIPS Arena might be, we could call it a replacement of some kind. I would think that, people, both in the user and the DIPS side of the equation, will be thinking that it's not necessarily the last replacement. There'll always be new versions, but in a sense, the last replacement of the underlying design structures and information capabilities that really lie inside the product. Why are clinical users usually left out of system design? Now, this is pretty normal still around the world, although it's starting to change. So if we think about what possible answers there are, most current information systems in the clinical area aren't adaptive. Now, being adaptive is a property that a system has to have in clinical medicine. If it isn't, it's just going to be paralysed in its old requirements, and the requirements of the users keep changing, they diverge, and the system gets further and further away from serving the users. And that's extremely relevant in health. So there's a lot of costs involved in this problem of replacing systems, and I've just put a few of them on the screen. The inability to adapt creates costs. For example, doctors and other people creating what we can think of as secret departmental access databases. Okay, it's not necessarily in access literally these days, it could be in something else, but you know what I mean, secret databases, usually with very good information, and it's because of frustration by, could be specialists, it could be some other part of researchers or people who can't get any flexibility from the main solution. Other peripheral systems might be added to compensate, maybe without even the knowledge of the main, the CIO and the official IT program in a hospital. So if you go to large hospitals, you typically find, if you do let's say an honest count of how many systems there are, it'll be in the hundreds, which is, having hundreds of applications wouldn't be scary, but having hundreds of representation of similar clinical data, that is scary. So there's lots of costs there if adaptiveness isn't a characteristic of the system. Costs of not engaging clinical users. Well, there's an obvious one. The system doesn't do what they want. By the time it's delivered, what's on the screen, they start thinking, this is crazy. Did they forget, these 5 things that we're always using? But how do we join that gap? Because clinical people have very specific understanding of their own information, and it's quite often complex. IT people simply cannot, unless they're already a doctor or something, but normal IT people can't hope to understand most of it. They can get their head around labs and those kinds of things, maybe prescriptions, but if you're talking about, the kind of information in an antenatal visit or any normal physical examination, that's doctor's stuff. So there's no point IT people trying to pretend that they can just ask a bunch of questions and get the detailed, correct information and workflow structures from the doctors. So we need a better way. So another question it's interesting to raise, why is there really no decision support industry in health? There's a lot of academic stuff going on. You can't go and buy many products that you can just deploy in your hospital. Why do computerized clinical guidelines remain a largely academic activity? Well, historically there's been no standard way to talk to the EHR and no standard way to query the EHR. So if you're building a decision support product or some sort of guideline evaluator product, there comes a point when inside your product, you have to write something, which is something like queries or software that's going to interface to the health record. How do you write that software? Well, today it depends on what the database looks like, or different products' interfaces to their software look like. The querying will depend usually on the physical layout of the database, or you're forced to use a data warehouse approach and extract the data from the primary clinical system into some structure that you think you can deal with. But then, so let's just remember that we're talking about a clinical decision support product. You're essentially asking that for anybody who wants to use that product, first of all, you've got to do an extract, transform, load of your data before you can even use my product. But that's crazy, because the product might be for point of care. So you can see that there are reasons why this industry doesn't really exist at the moment. I did a little bit of maths just to think about what would it cost if you were a builder, a vendor, or an IT department building a little clinical decision support or guideline evaluator product. And I put some, I think, low estimates for the amount of work and the number of queries in a guideline that would enable the guideline to be evaluated against real data. So for all I know, I mean, there are experts on this in the room, I'm not one of them, but they might just put a 0 on the end of that 8 and say that it's 80 person years. Now that's not an impossible amount of work, even if it was 80 or 20 person years or whatever. If you were a company building a very good quality decision support product, if you only had to spend the 8 person years or 20 person years once, and you could then sell your product and it would work in all of the places that you sold it for essentially no extra cost or very little extra cost, that'd work. That's going to be okay. Unfortunately, that ain't how it worked today. So these are the kind of problems that we have. So what's the OpenEHR approach? I would summarise it as a semantic architecture designed to flexibly standardise data. So that means the sort of concrete representations of, you know, quantities and dates and times and chunks of text and codes and also just structures. You saw in the presentation yesterday from Thomas or Bjorn, I forget which one it was, but it had some of the OpenEHR higher level structures like entries, you know, observations, actions, instructions. This is data in OpenEHR terms. Content structures, so that's these archetypes. So now we're talking, you know, blood pressures and blood gases and every kind of vital sign you can think of, antenatal examinations, anything medical. So we're talking tens of thousands of things that clinical professionals would record, either seeing a patient or doing some lab work or doing anything inside the health system on behalf or for a patient. Any clinical information. The key thing, terminology use. So we've taken some care to include how to connect terminology being used into these archetypes. And lastly, APIs, so programmer interfaces to services and parts of the software like the EHR and demographics, but also higher level things like medication, managed medication list and those sorts of concepts. So the point here in OpenEHR is that the content is developed by clinical people. So I guess there's a lot of clinical people here today. It doesn't mean that you all have to do this. It probably means that a small percentage of you have to do it, or you know, there's always a few geeks lurking in the crowd, let me put it that way, even amongst the clinical people. That's a good thing, because they tend to be the people who can easily translate between the clinical knowledge, let's say it's nursing workflow for a particular type of ward, you know, pediatric ward or whatever. Those geek clinicians are the gateway between the knowledge that's embedded in the minds of all of you clinical professionals who work in hospitals and wherever else, and the technology. So now, and we can say it for DIPS Arena as a product, it can absorb models made by clinical people. So that's a really massive advance, because you can deploy the product and then a year later, you know, maybe a certain group gets around to modelling, I don't know, some cancer staging stuff, does anything, just think of a clinical area, and they produce the models and the system will just start absorbing it. Now you might have to add some screens. It's not like it's there's no work in the software area, but the point is that the back end producing all those terabytes of clinical data will just keep going. It doesn't care whether you start throwing new content at it. It understands the structures because it has a standard way of understanding all structured data, no matter how you've labelled the pieces in the clinical sense. So this allows us to build adaptive systems. Now the last thing on the list there, making querying based on content, I just want to mention it a little bit today, because we often think, well, sometimes we get obsessed with how does the data get in, and we don't think enough about how does the data get out. But we put data in once, we get data out, it could be 1,000 times. So that's a little bit more just the engineering side of the OpenEHR approach. So it's a services-oriented architecture, and with some specifications about how systems talk to each other, EHR, extracts and various things. But these are the key things here. Flexible semantic architecture, content developed by clinical people or domain experts, adaptive systems so that the software isn't dependent on the models, those content models I mean, and querying based on those models, not on the concrete schemas. So in pictures, I think everybody here is going to be very familiar with this way of thinking or something like it. So we've got a screen. Now, mentally you need to replace it with some beautiful Dips Arena new kind of screen. But that's what's on the user interface. At the level below that, there's something called templates, and it was mentioned a few times in some of the presentations yesterday. So a template is a kind of archetype whose job is to express a data set. For example, the data set in this form here. Underneath that, you have these archetypes. So the archetypes do things like give you the model or the definition for HbA1c, the data points inside physical exam, or anything else you can mention. So the ubiquitous blood pressure, things that you only want to define once. So let me just ask you the question: how many times would you like to be forced to define systolic blood pressure as an informational concept from the clinical fraternity here? I hope the answer is only once. Why would it be more than once? Now, if I ask the same question for something more complicated, like microbiology result, I hope the answer is still once. Why do I want to have multiple definitions? I don't. So going backwards up the tree, up the stack, if you like, the question here that templates answer is, how many times am I going to use the definition HbA1c or blood pressure or microbiology result? And the answer is, well, hundreds or thousands. How many forms in my system? How many times do vital signs appear on the forms in the system? It's all over the place. So templates equals data sets, archetypes equals a library of content definitions that we only want to define once. They're defined in archetypes and grouped together because if you think about the group of things in an archetype, and I'll go back to blood pressure, it's everybody's favourite, you've got a number of data points together. They all fit together: systolic, diastolic, patient position, cuff size, various, the inclination of the patient, that kind of stuff. All of those are related, so it's reasonable to put them in a little group called an archetype. The bottom level here, as I've already mentioned, is the information model, or we call it the reference model in OpenEHR. So I've just drawn this out a little bit more. I'm not going to spend much time, but if you want to look at the slides and just think about it, the point here is that one template can easily be displayed in multiple ways. So the actual physical display it's up to the system or to the application or to aspects of the system architecture. So that's the relationship between archetypes and templates. So that's the concept of an archetype being reused in many templates. And the basic elements of archetypes, you see this little Q meaning quantity, this is a little cluster, this is a ratio, this is a text. Where do those things come from? And a cluster that breaks out into a tree, so where does the definition of the tree structure come from? It's all from this reference model here. So a lot of current information systems don't really solve the problem of having a library of definitions that can be used in data sets and that then can be displayed, because they've got a too simplified architecture. And one of the biggest problems is that they've only got a SQL to be used against a proprietary database. So getting the data out, that's what querying is about, obviously, is very dependent on the physical structures of the database. So, a little bit about seamlessness. You can see that there's lots of cats in different moods here. So if you see a sad cat, you know there's something bad going on. This is a very cunning cat. So here's the cunning part of OpenEHR. that little graphic just shows you the same things kind of in a different arrangement, reference model, archetypes, templates, some connection to terminology via what we call bindings. I won't go into the details. Queries based on archetypes. So templates. We build a template. What can we do then? Well, with tooling we can build something called an operational template. It's just like a giant archetype. If you had modelled just the information for that one form that you're trying to design, the operational template looks like that. But of course it's reused a lot of things, but the result is as if you had built it de novo. And from this, now this is more like software land. There are tools that will generate all kinds of what we can think of, what we can call downstream artifacts. So now maybe the software people in the audience might be mildly excited, and I think DIPs are doing at least some of these kinds of transformations, probably some specific ones that would make sense inside the DIPs product. This is important because it means that a definition over here, you can think of your blood pressure or blood gases or your microbiology, that clinical people developed will end up seamlessly over here in a message definition or a document definition, which let's just say that it's an XML schema or some sort of concrete thing that software people can use. That's the seamlessness. And I haven't drawn it on here, but these queries are now able to be used on this data. When the data are created, or it could be created by the use of these APIs, so I'm talking about real EHR data. How do you query it? With these queries written over here. So the point here is that we can engage software developers. We can just give them some fairly normal types of things, artifacts, which they can use. And I'll give you an example. In an XML schema built from an operational template, let's just say it was a lab result template, and it had serum sodium and serum potassium, very standard kind of lab analytes. There would be a tag in an XML tag, so that's something that tells the software person what the data is here, and the tag would say serum sodium. And it could say it in Norwegian. We can generate it in Norwegian or any language. So this is a software artifact that a person who might not even be very good at English, why should everybody be good at English? Let's have it in your own language, please. Who doesn't know anything about OpenEHR, why should they be good at OpenEHR or Archetypes? We can't employ everybody who's a PhD in health informatics. Sometimes we just need good software developers, and we give them something, and they've got to be able to spend maybe 1 hour studying it and be useful, do something useful with it. So that's the point of these downstream artifacts. Turning all this sort of cerebral rocket science stuff that very smart clinicians put together, models of clinical information, into directly usable software artifacts. Let's think about a big picture. Who does what in the overall structure of things? Some of you know that there's a thing called a clinical knowledge manager. It's a product that, well, my company produces it, but don't think about it as a product so much. Think about it as a repository for models, that is archetypes and templates. So there is one at openehr.org, but when I say remote CKM, it might be it could be a national repository for the country, like Australia has a national repository that works like this. So there might be some archetypes, and typically it's things like vital signs and basic labs and all these sorts of things that have already been developed. Probably you don't need to go and build your own blood pressure archetype, and there's probably some hundreds of other archetypes that are pretty standard, even things like cancer staging and so on that are based on well accepted international protocols and concepts. So let's take some of those, reuse them, and there are ways of reusing things and specializing them. Build a template, connect it to terminology, generate the operational template, run transformations to get the kind of downstream artifacts you want, And all of this could be managed in a CKM. Now again, if this was an international one, this might be a national one, or this might be one, it's not impossible to imagine that, for example, the DIPS as a large vendor might have a product like this running, doing this job, enabling all of this development to happen here. So this kind of workflow is going on in a few places in the world. It's about to start in the UK. It's been going on in Australia for a few years. It has been going on in Sweden. It's a bit unclear what the current status in Sweden is, but it's growing actually. Brazil is about to start doing this, and so is Slovenia. So depending on what kind of person you are, and I mean even the people in the room here in Norway, you could be involved at the international level on some of this modelling, or you might get involved in some national, or even, I don't know exactly how it's going to work out in Norway, regional effort. So that's clinical people. There may be the idea of standard templates being built. Again, it could be at a national level. Some countries try to standardise things like discharge summaries and referrals and so on. It could be that the downstream products are going to be consumed by somebody, and that might be a vendor. Now, DIPS is a kind of, I would say, almost a unique company in my experience. It's likely to be involved or have people involved almost at all levels of this overall situation. Clinical people, that is the user side, I guess are likely to be involved primarily over here. So there's a big opportunity actually for people in Norway to work with a vendor that's going to build something based on your models, but also to work not just inside Norway in the way that you normally would, but to work with international context, sharing and obtaining models and reusing effort rather than having to invent everything yourselves. So that's just a picture of the development ecosystem. There are tools for building the models. That CKM thing is shown here, so the idea of a model repository and tools for managing models inside a repository, tools for building applications, and then deployable software. So you can think of the deployed DIPS product is the blue part, and then inside the DIPS, let's say, development ecosystem, at least there's these some sort of tools. Well, actually they're using some of the available tools from OpenEHR to do some of the modelling, and over time they'll undoubtedly build some special DIPS specific things as well. So we have forms and messages formally based on content models, and we have deployed system, which can be, it's large scale software, and it will create large amounts of data, and the data really matter in health. You can't mess around with the data, you have to be careful with it. So now we have the data being produced by the system being based on models, but we also have the system with the capability to just continually absorb new models without having to be upgraded or migrate the data or do any of these bad things, which are serious problems when you've got large amounts of mission-critical data. Just a few ideas about querying. Like I said before, you put data in once, you get it out many times. It could be at point of care, it could be during the hospital episode, it could be for research purposes later on. So there's a lot of economic value in the data. So querying is very important. So in OpenEHR, querying is based on the models, these archetypes, and also terminology, rather than on relational or physical database structures. Okay? Clinical people, at the moment you probably don't care about it too much, but at some point in the future you'll be using a tool that DIPS or somebody else makes to write queries, and you'll be thinking in terms of I'll just go to the, there's a picture here somewhere, I hope. Maybe I haven't got it. But you'll go to the archetype models and you'll be building the queries based on data points defined in those models. So the result of doing that kind of query definition is that no matter what software is being used, what forms or whatever, if blood pressure, let's just take an example, is being stored by these different forms, captured in different general practice or different types of clinics, we should be able to run a query which extracts that because it knows that it's a standard reference model, but it also knows that it's the same archetype, that is the blood pressure archetype, and it knows the data paths to extract these data points and put them on here. And this is what's happening today. This has been happening for some years in a number of software products. So I'm nearly done. I'll just quickly show a query. So there's an example query that's got a little bit of complexity in it. There's some archetypes. So I'm just going to point to the two key fields, HbA1c and diagnosis. So if you see what the query was, you can see that those two fields relate, are the clinically important things. So imagine if you had a tool that allowed you to extract those two things and build a query. Then somewhere in your query building tool, the path to the particular items that you want will be extracted. You won't see this. It'll be in the back of the software somewhere. You won't really care. It'll get done magically. So there's a real query. Now that looks horribly complicated, and there are tools that are routinely used to build these kinds of queries in systems today. And these kinds of queries are used for population querying and routinely for populating screens. I won't go into it. I hope you can believe that it's a pretty routine technology that's in use now. Solely based on the information model and the archetypes, that is, the content models. So the queries have no knowledge of the physical persistent structure. Querying requires a query language, and there is a query language in OpenEHR. You can have a look online. So, big picture, last couple of slides. Just my very quick summary of what OpenEHR provides. We haven't talked much about terminology, but the ability to reliably use terminology in a known way is obviously a key thing, and it's growing today. It's going to keep growing. Some new initiatives that are going on around the world in the US have now adopted ADO 1.5. So the message here really is that you're on a good thing. Don't think that archetypes and things that DIPs are talking about is some sort of strange choice of odd technology. It's going mainstream and it's getting picked up by a lot of countries and companies. And Gunnar Klein, he'll talk later and he'll give you a better list of where it's being used. So that's, I've made a few quick points about how you might think about this in Norway. There's a few things happening here, and I think the future is extremely exciting for you guys. Maybe you don't realize it, but I think you're really on the forefront, almost I would say, of the whole world of health informatics. And I'll tell you why. It's because you've got a symbiosis of a vendor and a clinical community, and a good symbiosis. So that's it. Thanks for your attention.
Thank you.